So in this video, I want to walk through the study application with branching, one of the last assignments, and point out a few things. So first, I'm going to run it. I'm going to put in my name, ready to begin. It's going to ask me a couple of questions. They're going to be presented in random order, and actually the order of these options is also randomized. So what's a Boolean? Let's answer this one correctly. I'm going to put in 2. Correct, I got a point. What is a declaration? Let's go ahead and answer this one correctly too. Got another point. Let's answer this one incorrectly and see what happens. So a function, let's say that this is an infinite loop. And for this last one, let's try typing in, 5. Whoop, it's going to tell us that's not one of the answers. Go ahead and pick something, and let's go ahead and put in the right answer. And so at the very end of the game, we get this final score, we get some feedback based on how we did, and then there's a little bit of a credit screen that says where that ASCII art came from. Okay, so this code is going to be posted along with this video on Canvas, so you can download the code, you can step through it. That's what I recommend doing because I'm going to go through this pretty quickly to just highlight a couple key points. But anytime you're looking at new code, you want to start at the entry point of your application. And we know for all C# console applications, that's going to be this main function inside of program.cs. So we can see that creates a new study application instance. It is calling the run method. So if we're tracing this, we know we want to look at the constructor of study app to see what happens there. And then let's look at the run method and see what happens there. So in the study app, we can see there are a couple fields created. We've got our constructor, which looks like it is displaying a welcome message. It is asking for the player, creating a player. It's doing something to create an array of terms that gets displayed. It does something called shuffling in place. That's the end of the constructor. And so then the run method that we saw that gets called asks the player if they want to begin, waits for a key, displays all of the terms, checks the score, and then displays a credit screen. So then we could dive down deeper and see, well, what does display terms do? What does check score do? Display terms loops over all of the terms for each one, clears the screen, checks or prompts the player for the definition of the current term. If it's correct, it goes ahead and if the player's answer is correct, it goes ahead and increments the number of points. So adds 1 to current player.points, displays the score, and this keeps going for all of the terms in our application. And when that's done, we saw that check score gets invoked. So check score prints out the final score. It takes the player's points, prints out the total terms, checks whether it was a perfect game, if they missed one, and prints out some feedback that's based on how they did. So at this point, in reading the application, we could dive into any of the classes that we've kind of skimmed by. We saw that up at the top there's a player class, so if we wanted we could dive in there and look at how does the player class actually work, or we could look into the term class and see, well, how does the term class actually work? Oh, it's got a name and a definition and a bunch of options associated with it. So this is the way that I would encourage you to think about tracing down code that's unfamiliar to you. Start at the entry point, try and get an idea of the overview of what's happening, and then dive down deep into specific classes and methods as need be. So there were 2 big challenges in this assignment that folks usually have some trouble with. One is, how do we get this logic to work where we can track the number of points so that at the very end of the game we could print out a score report? The other one is, how do you randomize things? That's challenging. So let's start with the tracking the number of points, and then we'll look at randomization. So for tracking the number of points, we saw that there's this logic here where each term, the prompt for definition method runs, returns a Boolean. If it's correct, then we can go ahead and increase the number of points. So let's hop over to the prompt for definition method inside of our term class. So this asks, what does the term mean? And then don't worry so much about this logic here. You can walk through it more slowly by downloading the code and checking it out. But we can see that it prompts the user for a choice of definitions. It checks whether what they chose equals the term's actual definition. If so, it prints out a nice message and then returns true. If not, it prints out that they got it wrong and returns false. And so a lot of folks in their method that looks something like this, prompt for definition, where your term presents the question to the player. People's first impulse is to do something like this, current player dot points plus plus, which is going to give us an error. And if we hover over it, it's like current player doesn't exist in this context. So if we scroll up, the term class, it knows the name, the definition, and the list of possible answers, but it doesn't know anything about the player. And if we think about responsibilities, what each class in our application does, it doesn't really make sense for the term class to know about the player. That would tightly couple two things that are somewhat unrelated in terms of the application. And so one way to get this logic happening, where when you get the answer right, we increment the number of points, is that this method, instead of actually trying to increment the points directly, returns true or false. So in the study app, which is the class that orchestrates all of our logic and actually has a current player instance. If I scroll up here, we can see it's got an instance of the player. It creates it here. So by returning a Boolean from prompt for definition, the study application, which is responsible for knowing about the player, can go ahead and apply the increase in points when it's necessary. Okay, so that's one way to deal with incrementing the points and keeping track of them so that you get a final score at the end. The other challenging thing was randomization. So in my version of this application, the list of terms is randomized up here using this shuffle array in place method. So all of these get presented in a random order. And actually also, if we dive into term, when we go to present those list of options, the options are shuffled so that it's harder for the player to just memorize like, oh, the first one's 1, the next one's 2, the next one's 3 in terms of right answers. They're shuffled, so you actually have to know the terms a little bit better. So let's start with maybe an even easier version of randomization. If we go back to the study application, I'm going to temporarily change this because actually it's going to be a lot easier to start by randomizing a list than randomizing an array. So what I'm going to do is, let's comment this out. I'm going to make a list terms, and we can go ahead and comment this out. And I'm going to pause for a second to write the list version. So we have this list here. It's the same structure as what we had with the arrays. So it's a blank list, then one at a time we add new instances of the term class, one for integer, Boolean, void, and declaration. And so before we jump into code, it's probably useful to switch over to a whiteboard to just kind of diagram what's going to happen. So we've got, I'm going to represent these by just like writing out the words. So we've got integer, Boolean, declaration, and void. And what we've seen before is we know how to randomize something, pull a random element from a list or an array, where we can say, give us a random number, and I'm going to put the indices here. So we've got 0, 1, 2, 3. So we can use the random class. So we can say random RNG equals new random. And we can use the next method to get a number. If we pass in 0 and 4, that gives us a number between 0, 1, a number that's either 0, 1, 2, or 3. So that would give us an individual random element from this list or from this array. It doesn't matter actually which it is, because this gives us the index, we can pull it out and then display it. But the trouble is that if we were to run this multiple times, we could potentially, the first time, get 0, then maybe we would get 2, but then maybe we'd get 0 again. 3, maybe we'd get 2 again. So this doesn't actually work to give us a random sequence of these 4 definitions, or of these 4 terms. What we actually need to do is somehow, when we're randomizing, make sure that we remove integer after we display it. So we would want to do something like when we pick from here, we get integer, and then we go ahead and remove it, and then do another randomization of just these three, and then maybe we get void, and then we can remove that and keep going. And so one way to do that that's easy to do with lists, so I'm going to undo some of this and then give us some space. So with a list, we know how to actually add and remove on the fly. So what we can do is pick a random element from this list, and let's say then we got Boolean as our first random. So I'll put that down here. We would remove this, and our new list would be int declaration void, and then we could pick randomly from this new list, and maybe we'd get void. That would get removed, and our new list would be 0 and 1 int declaration, and so forth until everything has been removed and we have 4 random elements. So let's say we got int this time, so int, and then the last time we ran it we got declaration. So we would have our random sequence going through this step-by-step process of picking a random one, getting rid of it from the list, picking a random one from the remaining list, getting rid of it, and so forth until we're out of elements. So let's flip back over to code and let's do that. So we've got our list, integer, boolean, void, declaration. If we come down to where we're actually displaying the terms, I'm going to go ahead and comment this out because this was our code for what we should do if there's an array of already shuffled terms. But what we want to do instead is maybe something like this. We want to say, well, our terms.count is greater than 0, which means as long as we still have things in our list, let's keep running this, and we can do our random number generator. And so we can find, however big this list is, we can find a random index into that list. So let's say int random index is equal to our random number generator dot next, and we would say 0 to whatever the length of the list is. So however many things are in the list. And remember, this is exclusive, so this is going to give us a number between 0, 1, 2, and it's going to stop shy of whatever the count is. So when this runs the first time, we've got 4 things in our list, so we're going to get 0, 1, 2, or 3. And then when we remove something from this list, when we run that again, it's going to give us a random number between 0, 1, and 2. Remove something, a 0, 1, remove something, then it's going to give us 0, and then our list will be empty. And so going through this process, we'll end up presenting things in a random order. Let's come down here. So random index, we're going to go ahead, figure out what our random index is. We are going to do this logic. So let's pull out the term. And then we can replicate this logic, so clear the screen is correct. Prompt for definition, if it is correct, then go ahead and current player dot points plus plus. And I'm just going to copy and paste this bit. So we're getting a random index, we are getting the term associated with that index, and then we do the same logic before of presenting it, incrementing the points, and waiting for the next key to be pressed. So this is close. This will definitely do some randomization, but it's never going to remove those terms from our list. So it's possible to get the same term multiple times, and our loop is actually never going to end because the terms list always has 4 things in it. So let's see that in action. So it's asking about void. Oh, there we go. Perfect. It asked for void again. So it did a randomization twice, but gave us the same thing, which is something we definitely don't want. And I can keep playing indefinitely because that while loop is never going to end. So let's fix both of those by when we go ahead and pull out this term and store it, let's do terms dot remove at, and we pass in the index, we pass in our random index here. So we're going through our list, we're grabbing something random, we're storing it, and then we're going ahead and removing that. So if I hit play, type in my name, so we get Boolean, that's random, we get void, declaration, integer, and then we're done. So this is one way to shuffle a list, and as you start needing to shuffle multiple things in your code base, it starts to make sense to figure out how can you take this logic that we're doing here and turn it into a reusable method. So I will show you really quickly in the random utils that exists. So for one case that is actually used inside of terms to shuffle right here, shuffle the list of options so that when you present them, those numbered options, those are randomized. This method is actually used. So instead of just needing to write all of this code from scratch each time, if you are able to create a reusable method, you can bring that from project to project or use that across multiple classes. So this is a method that takes in a list of strings and then gives back a new list of strings that has been randomized. And it's really the same logic. It's a little maybe fancier with a little bit more polish added to it, but it does the same thing. It goes ahead, it has this loop as long as the list isn't empty, go ahead and find a random index, add it to our randomized list, and then remove it from that original list. And then at the end, you can return the randomized list. So go through this and check out some of the other code here, step through it to see some other ways to shuffle, because I'm showing you how to shuffle a list, but I also have some examples of how to shuffle an array in here. If that's something that you're doing in your code base, you can shuffle both lists and arrays. And if you're really feeling adventurous, check out some of the advanced random utils, which show you how to write code that is even more powerful using an advanced concept called generics. But don't worry too much if this doesn't make sense initially. Your takeaway from this should be that you know how, if you weren't able to get it working, you know how to now track the number of points that the player has from playing your game, and you know how to implement randomness in some form in your game. So take your time, download the code, step through it a little bit more slowly, compare your approach to what I did, and make sure that you understand how to do both of those things.